Assalamu alaikum warahmatullahi wabarakatuh. The last part of the chapter 19.7, right? In this section, we are going to learn about the combination of the resistance, right? It's very easy phenomena. Look at this. Now, have a circuit like this, negative and the positive side, right? Now, you have a resistor to give a resistance, right? We'll take this resistor as R1. Now, to this, right? Now you have a fixed value resistor. Now, if you want to do a change in the resistance of this circuit, you can't do anything other than using another resistance on this to this, right? Because this resistor is not very variable; it's fixed value. Therefore, you have to use another resistor to maintain another resistance, right? It can be done in another way, right? For an example, if the resistor maintaining a length of this, if you increase the length, you know that the resistance is going to increase, right? Therefore, you can connect the resistor in this way, another resistor in this way. What is going to happen? If the resistance of this is R1 and the R2 and R3, the length is increasing. Because of the length increase, right, we can say the total resistance, or we are calling it as equivalent resistance, right? Equivalent resistance is equal to R1 plus R2 plus R3, right? This can be illustrated in this manner. Look at this. We'll connect the voltmeter here, and the reading of the voltmeter is V1. Here we are going to connect the voltmeter, right, and the reading of the voltmeter is V2. Here we are going to connect the voltmeter, and reading of the voltmeter is V3. Which means across this you have V1, across this you have V2, across this you have V3, right? Then the current flow here is I. If the current flow is here is I, right? Normally, keep this in your mind. You don't want to worry about Y, right? If the current is moving through a number of resistance which has been connected in this manner, right? You know the connection of this manner is known as series connection, right? If this is connected seriously, right, then the current flow through this is going always equal to this, always equal to this. The current flow through R1 is I, again through R2 also I, again through R3 also I. Because if a current of I is released from the battery, the same amount of current should be gained or should be received by the battery itself. It should be, right? The exit value should be the gain value, right? The current, it should be there, right? If this will be possible if the current flow through R1 is equal to R2, is equal to R3 only, then all the current is going to be come to the final place, right? Therefore, if using these two readings by the V1 and R1, we can find I. How this I is going to be, look at this, this I is going to be equal to, right, V1 over R1 according to Ohm's law. This I, we can say like this as well. I is equal to V2 over R2, right? Again, this I can be written as V3 over R3 as well, right? Then the same I can be written in these forms, right? Now, by the meaning of the equivalent resistance, the total resistance means that you are considering a value of resistance instead of these three values of resistance, right? Then you are considering a resistance, right, which is present here, right, equivalent to these three resistance, right? We are calling it as R. Then what is the current moving through this R? That is also I. Then what is the volt? What is the potential difference between these R? That is going to be the total potential drop of these three. Correct or not? Right? Here, from here to here, how much of potential drop is there? Drop of this, and drop of this. All together, you have the total value of drop. We'll take the total value of drop as V. Right? Then I can say the V, now don't think about this now. Right? This V should be equal to V1 plus V2 plus V3. Because this all the V are the drops in the each and every places, then the total potential difference is going to be smaller potential, collection of smaller potential difference, right? Then V1 plus V2 plus V3. This V can be written as I into R. This R is equivalent resistance, this I is the current, I into R. This V1 can be written as I into R1. This V2 can be written I into R2. This V3 can be written I into R3. Therefore, IR is going to be equal to, if you take all the I's as a factor, R1 plus R2 plus common factor, right? It's going to be like this. Then I and I is going to be cut off, right? Then the R is going to be equal to R1 plus R2 plus R3, right? Then in a series arrangement of resistors, if you want to find the equivalent resistance, right, you have to add each and every resistors together, right? Do the exercise that is given in your book to the series connection, right, and send it to me today itself, inshallah. Okay, now the second type of connection. In a circuit, we can connect the resistors in this way as well. We are calling this as parallel connection. We take this as R1, this is R2, the value of this is R3. Right? Now I am saying a current of I is going to flow through this. I want to clear another law which is known as Kirchhoff law. Kirchhoff law, right? Kirchhoff's law, right? That is, if a current I is flowing through a junction, towards a junction, right? And if the current going from the junction is I1 and I2, right? Sum of the current going from the junction is going to be equal to sum of the current coming towards the junction, which means I is going to be equal to I1 plus I2, right? The sum of the current which come towards the junction is equal to sum of the current which is going from the junction. That is Kirchhoff's law. I am saying I is coming in this from the battery. The I is going to be here. This has been divided to 3. I'll take this as I1, this as I2, this as I3. Then according to Kirchhoff's law, tell me what is the relationship? I is going to be equal to I1 plus I2 plus I3. Right? I write this in this place. I is going to be equal to I1 plus I2 plus I3. Right. Now, here you have parallel connection of resistors. Right. sometimes to do some questions, you need an equivalent resistance, right? Which means a single resistor or resistance for this all values of resistance, right? Which has been connected parallelly. Okay. If you want to find the equivalent resistance for these three parallelly connected resistors, we'll take this as R, right? The equivalent resistance. The current flowing through this I, right? We can see. Now think this point and this point, right? The potential difference, if you measure the V in between this point, if you go through this way or in this way or in this way, all the way are connected to the same point. Because of that, all the ways are going to show you the same voltage difference, right? Because if you want to find the voltage difference across this R1, then you have to connect a terminal of a voltmeter here and a terminal here. If you are connecting here and here, also all are same because nothing is there, right? No resistance are there, right? Then connecting here is going to give you the volt value across this, at the same time this, at the same time this as well, right? Then in the all three ways, the potential drop is going to be V. Now, I am going to illustrate this I in terms of R and V, right? Now, I am considering a single value of equivalent resistance here, right? Which is named by R. What is the potential difference across this is also going to be V. Therefore, here the I can be written as V over equivalent resistance R, right? Which is going to be equal to I1. I1 is what? V over R1 plus R2 is what? Voltage different, the potential different divided by R2. Potential different divided by R2 plus the potential different in this way divided by R3, right? For this equation, if you take the V as a common factor, 1 over R1 plus 1 over R2 plus 1 over R3 are going to be the going to be in the bracket. If you cut these two, then 1 over R, the equivalent resistance, inverse of the equivalent resistance, so 1 over R is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is how we are finding the equivalent resistance. For an example, if R1 is 2 ohm, R2 is 2 ohm, and R3 also 2 ohm, right? Then what is the equivalent resistance of these three resistors, right? Then the equivalent resistance is going to be equal to 1 over R1, it's 2, 1 over R2, it's 2, plus 1 over R3, it's 2. Right? Then 1 over R is going to be equal to 3 over 2. If 1 over R is equal to 3 over 2, you need the R. R is the equivalent resistance. Then R is going to be equal to 2 over 3 ohm. That's it. 2 over 3 ohm. Right? This is how we are finding the equivalent resistance for a parallel connection. That's it. That is the parallel connection, and you can continue your work with this chapter and do the exercises, right, and send it to me to check whether you have understood or not. Okay, very sorry for the late teaching of this chapter, right, because of some problems and okay, some problems were there, right, to do this video. At the last moment, I supposed to do this. Right, I'm very sorry. I ask apologies from you. Right, and this is not. This is because of some personal problems. Right, keep this in your mind. And I'm very sorry to teach you in the last moment. And I have taught you this chapter very shortly, right, to understand in the way of understanding, right. I don't know whether you have got or not. Okay, right, go through your book as well and take this instructions to support your book, right, and do the questions that they are in the PSURU, the past papers, right. Try to complete the past paper, right, and I think you will better. You are going to do questions in the final paper, in your third term paper, and in your next year, right, you have a we have an application. You have a chapter to apply this phenomena, right. In that chapter, again we are going to discuss something about this, and in the paper class, inshallah, in this year, in your grade 11, inshallah, we will do questions related to the current electricity, inshallah. Our target is normally O level, but since I am not justifying me, I'm very sorry, very sorry to do this much of very nearby the exam, right? Really sorry, right? Go through this video, right? I hope all the video is going to be around 1.5 hours, right? 1.5 hours, you can manage it, inshallah. If you do this today, inshallah, you can work something tomorrow, and you can go to your exam, inshallah. Right? Barakallahu feekum, Allahumma barik. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.